Okay, good morning everyone. Okay, so today we're going to discuss on the topic of properties of circle. Okay, we're looking at this question from EMATS O level question year 2011, paper 1, question 14. Okay, so let's go through the question together. ABCD is a cyclic quadrilateral. When produced, the lines CB and DA meet at M. When produced, the lines of BA and CD meet at N. DMC, angle DMC is 28 degree and angle BNC is 22 degree. Okay, given that angle BCD is x degree, find an expression in terms of x for angle MDC. Okay, so the angle MDC is this one, right? This is the angle MDC. Okay, so in order to find the angle MDC is quite easy, right? You can just see, MDC is actually a triangle, right? MDC. Okay, so if we focus just on that, you will see that the sum of angles in a triangle is 180 degree, right? So the angle of MDC, it's equal to 180 degree minus 28 degree minus x degree, right? And this is a angle in a triangle, right? So what is this equal to? Let's get out our calculator. Just 180 minus 28, it's 152 degree. 152 degree minus x degree. Okay, so this is the angle MDC. Now, part 2 says what is the angle NBC, right? The angle NBC. So same concept. You see that there is that triangle. This is the triangle, right? NBC. So if you just want to find what is the angle NBC, what you do is that you 180 degree minus 22 degree minus x degree. This is the angle in a triangle, right? So we get 158 degree minus x degree. Okay, now part B says use your answer to part A to find what is x. Okay, so let's just move to the next page. So angle MDC is 152 minus x. So this, right, is 152 minus x, right? And then NBC is 158 minus x degree. So this part over here, this is 150 ips. This is 158 minus x. Okay, so you remember that the opposite angles in a quadrilateral in a circle is equal to 180 degree. So this side, the angle MDC and the angle NBC, right? You see that they are opposite angle in the quadrilateral. The quadrilateral is this, right? ADCP, right? You see this? This is a quadrilateral in a circle. So the opposite angle is supplementary. Okay, so with that you can find out already. You can just put here. Okay, angle NBC plus angle MDC equal to 180 degree. And reason is because opposite angles, okay, opposite angles in quadrilateral in a circle is supplementary. Okay, supplementary means it's the sum of it is equal to 180 degree. Okay, so we can just put here NBC is 158 minus x, then you plus MDC, which is 152 degree 152 degree minus x degree equal to 180 degree, right? So x and x, 158 plus 152, this is 310, minus 2x degree equal to 180. So 2x degree it's equal to remember algebraic rule. If you okay, let's do it one by one. Okay, so over here, you want to move the 2 to the other side, and so you just plus 2x over here, the left hand side and the right hand side you plus 2x, so it is equal to, okay, let me just write a proper plus here, it doesn't look so nice. Yeah, okay, so 310 minus 2x plus 2x over here, it cancels, so it's equal to 310 is equal to 180 plus 2x, right? Now you want a 2x on the right hand side, so you just minus 180, so they cancel off on both sides. So over here it cancels off, so 310 minus 180 is equal to 130. Okay, so 130 equal to 2x. Now you want to find out what is x, right? So you divide by 2 on both sides, right hand side and left hand side, you get what is x. Okay, so x is equal to 65 degree, right? 65 degree. Okay, nice. Okay, so x is 65 degree. Okay, so the next question we are going to solve together is from the year 2011, paper 2, question 3. Alright, so the diagram shows a circle ABC with center O. AP and BP are tangents to the circle. Angle APO is 36 degree. Let's find the angle AOP. Okay, so the question is interested in this angle AOP. Alright, so as we can see here, if AP is tangent to the circle, that means this angle OAP is 90 degree. Alright, so if you want to find out the angle AOP, what you do, angle AOP equal to 180 minus 90 minus 36 degree, right? Basically this is just the sum of angles in triangle, correct? So 90 minus 36 is what? 54 degree. Alright, okay, let's solve 2a part 2. Okay, let's find the angle OBC. Okay, so now the next questions, this angle, so this is 54. Next question, angle OBC, this angle. Okay, we understand that the OP, right, the line OP bisects the angle AOB such that AOC angle POB, it's equal to angle POA. Okay, POA just now we found out to be 54 degree, right? So this is also 54 degree. okay, because it bisects. When it bisects, then the angle the line PO divides angle AOB equally. All right. Okay. Now that okay, we know also that OB and OC are radii of the circle ABC, right? So when this the radii, that means the triangle OCB is an isosceles triangle, which means that this the feet, the isosceles triangle, we know it to be the same angle, right? So let's find out what is the angle ACB. Sorry, the angle OBC. Okay, so the angle OBC, it is equal to 180 minus 54 divided by 2, right? This is angle in isosceles triangle, right? So this is equal to 180 minus 54 divided by 2. This is 63 degree. Okay, and let's just put here over here. Okay, so this is the answer to 2A part 2. Alright, next, okay, let me copy. So this is 90 degree, this is 54 degree, this side is also 54 degree, and base is 63 degree, right? This is 63 degree. Okay, let me just write it down nicely here, so that it's not so ugly. Alright, now part 3, we want to find out what is the angle ACB, right? Angle ACB. And we know angle ACB to be half of the reflex angle AOB, right? And this is just the properties of the circle, which is that angle at center, reflex angle at center equal to 2 times of angle at circumference. Okay, so this is just the property of circle. Okay, and when you do this, so we know okay, so let's find out what is the angle at center, right? Angle at center, reflex angle at center. Reflex angle at center is equal to 360 degree minus 54 degree multiplied by 2, right? So what's the answer to this? 360 minus 108, this is 252 degree. 252 degree. This is the reflex angle at center. Now we want to find out what is ACB, right? So ACB, we just use half multiply by 252 degree. And what do we get up there? 252 divided by 2 is 126 degree. Okay, so this is the answer. 126 degree. Okay, now let's solve part B. Given that the radius of the circle is 6 cm, find the area of the quadrilateral AOBP. Okay, so AOBP consists of two congruent triangles, right? Which is triangle OAP and triangle OBP, right? So if we want to find out what is the rate, first of all, the area of the triangle OAP, so which means, okay, let's just write it down, quad area of quadrilateral AOBP is equal to 2 times, okay, the triangle OAP, right? So this is 2 times of what is the triangle. So we know the height, which is the radius 6 cm. We multiply by half and we multiply by the base. So how do we get the base? We can get it using the Pythagoras theorem, right? The Pythagoras theorem says that tangent 54 is equal to the opposite, which is the base, in this case AP, divided by the radius, which is 6 cm. So AP equal to 6 tangent 54. 6 tangent 54, right? And we just cancel it off. Let's say 6 tangent 54, 49.5 cm square. This is 3 significant figures, alright? Okay, before we go on to the next question, I would like to prove some theories regarding angles in a circle, okay? So the first proof I would like to show you is a proof that angle in a semicircle is equal to 90 degree. So if you look at the circle over here, you will see that, okay, so this is the center O, okay? This one is the center O. So the radius, the diameter of the circle forms part of the triangle, and then the corner, one of the corners of the triangle touches the edges of the circle, okay? So in this case, right, you will notice that it will always be equal to 90 degrees. So let's prove that, okay? So first of all, we like to draw this another radius, okay, over here, okay, and let's assume that, okay, so let's give it a name, okay? So over here, let's call it A, here B, and here it's C, okay? So the angle OAC, let's assume it to be X, okay? X degree. So if OAC is X degree, OCA is also X degree, right? This is isosceles triangle, right? Because the length of the radius is the same, therefore it is an isosceles triangle, and thus the fit at the angle at the OCA and OAC is the same. Now let's assume that OBC is equal to Y degree, okay? So if OBC is equal to Y degree, OCB will also be equal to Y degree. And the reason is because of isosceles triangle. The radius, the length of OC and line OB is the same, okay? Now, in this case, what you have is, looking at the triangle again, it's a big picture, triangle ABC. You will see that the edges, which is X degree, Y degree, and X plus Y degree, right? Okay, and we also know that sum of a triangle, sum of angles in triangle is 180 degree, right? So which means I can say that X plus Y plus X plus Y is equal to 180 degree, correct? So now what do we get over here? X and X, 2X, Y and Y, 2Y, right? So we can put it that way, 2X plus 2Y is equal to 180 degree. Now we can take out the Y, right? Factorization. So it will be 2X plus Y is equal to 180 degree. Then X plus Y is equal to 90 degree. So no matter what the angle X and Y is, right? X plus Y will be 90 degree. Therefore, over here the angle is actually this angle is 90 degree, right? Okay, so that's a proof that angle in a semicircle is 90 degree. Okay, next we are going to prove that angle in same segment are equal. Okay, so now we want to find out right, we want to prove, okay, that the angle BDA, which we assume to be alpha, it's equal to the angle BCA, which we assume to be beta. Okay, and so how do we do that? Okay, first of all, what we can do is that we can draw from the same segment, right? We draw a line towards the center of the circle. Okay, towards the center of the circle, and this center, as usual, we'll call it center O. Okay, so okay, maybe I shouldn't draw it over here. Okay, just call it O. Okay, you know it, this is O. Okay, so basically we want to find out, so we know, right, that the angle over here, if we assume it to be 2x, right, so this angle 2x, the angle at the circle from, and at the center of the circle, if we extend it to the circumference, then the angle at the circumference is actually half of the angle at the center of the circle, right? Which means, what I'm saying is this is I will not prove this because this is part of the theorem already. So the angle BOA is actually twice the angle BDA. Okay, and similarly, the angle BOA is twice the angle BCA. Okay, so the angle BOA is 2x, right? We know it, 2x, and the angle 2 times BDA. BDA is alpha, right? Alpha. So so if we cancel this out, we'll realize that alpha is equal to x, correct? So okay, let's just, okay, x equal to alpha. Okay, and in the same way, BOA, right? BOA is 2x, so put here 2x, then equal to 2 times of BCA. BCA is beta, right? So when we cancel this off, we'll notice that x is equal to beta. So from here you can conclude, right, that alpha is equal to beta because x is equal to alpha, x is also equal to beta. So therefore, alpha is equal to beta. Okay, so this is the proof for angle in simsecond. Okay, the next proof that I would like to show is angle in cyclic quadrilateral. Basically, the angle in opposite segment add up to 180 degree. So remember, in a cyclic quadrilateral, all the edges must touch the circumference of the circle. Then it is considered a cyclic quadrilateral. Okay, so the angle in opposite segment add up to 180 degree. For example, this is alpha and this is beta. So alpha plus beta will be equal to 180 degree. Okay, so let me use a different color just to illustrate. Okay, so how do we prove that? Again, we'd like to draw the radius angle at the center of the circle. Okay, so let's do that. Okay, it doesn't look so nice, but imagine, okay, the center O is over here. Okay, so we know, right, from the theorem that angle at the center is 2 times the angle at the circumference, right? So this is equal to 2 alpha, correct? And then over here also, of course, the angle over here is 2 times the angle at the circumference. So this is 2 beta, correct? Now we know that 2 alpha, the degree, right? The total degree around the circle is 360 degree, correct? So we know that 2 alpha, and if we add 2 beta, this is equal to 360 degree, right? So we can factorize, we take out the 2, so alpha plus beta, this is equal to 360 degree, and alpha plus beta, this is equal to 360 divided by 2, which is equal to 180 degree. So you can see that alpha plus beta, no matter what the value of alpha and beta is equal to 180 degree. Therefore, the angle in opposite segment add up to 180. Okay, so let's solve this question from the year 2019, paper 2, question 6a. The question states that A, B, C, D, E are points on the circle, center O. AC is diameter of the circle, angle OAD is 23 degree, and angle ADE is 42 degree. Find giving reasons for each answer. Angle ABD. Alright, okay. So the question asks for this angle, ABD, right? This angle ABD. Now, in order to solve ABD, the other angles obviously, right? So we know that angle ABC is 90 degree, right? This is the angle in a semicircle that we proved just now. So this is 90 degree. Okay, let me just draw it. Yep. So angle ABC is 90 degree. Okay, maybe just to make it a bit neater. Let me just try it like that. This is 90 degree. This is what we want to find, right? ABD. Okay, so the angle ABC is 90 degree. And, okay, let me just write it down so it's clear. Angle ABC is equal to 90 degree. And this is angle in a semicircle. Alright. Okay. And we also know that angle DAC is equal to the angle DBC. Do you see? Do you see that this angle DAC, which is 23 degree, is the same as the angle DBC, which is this one, right? Do you see? And this is the proof that we did also just now, right? This is angle in same segment. If you see, both the lines actually originated from the point DC, right? They are from the same segment, right? This is the line and this is the line. You see, they're from this point, all right? So that's why they are angle in the same segment. So we can write that down. Angle DBC is equivalent to angle DAC, right? And DBC and DAC is equal to 23 degree. So angle DBC is also 23 degree. All right. Now you get what is the angle DBC, which is 23 degree. And you also know this is a right angle, 90 degree, right? Now you want to find out what is the angle ABD. And in order to find out the angle ABD, all you have to do is just 90 minus 23 degree, right? And you get what is the answer. So what is 90 minus 23 degree? It is 67 degree, right? Okay, so this is the answer. Let's solve for part B. Part B says find the angle EAD. Okay, if you see over here, this is a cyclic quadrilateral, right? Do you see here that they are this is a quadrilateral, and each edge actually touches the circle, right? The edge of the circle. So there is a cyclic quadrilateral over here, and you can see that the angle AED is 100 degree of the angle ABD. This is the proof that we did also just now. This is angle in opposite segment, right? So let me write it down. Angle AED is equal to 180 degree minus angle ABD, right? And this is angle in opposite segment. Okay, so 180 degree we minus of 67 degree, and what do we get? We get 113 degree. Okay, now we know what is the angle AED. We also know angle ADA, right? So let me just write it down here. So this one, angle AED is equal to 130 degree. So what is the angle EAD? This is easy, right? Because this is just a sum of angles in triangle. 180 minus 113 minus 42. And what do we get? 25 degree, right? This is just sum of angle in triangle, right? 25 degree. So this is the answer. EAD is 25 degree.